Hey everybody, this is my 3-point hitch style log splitter. You'll notice that there is no motor and no hydraulic fluid reservoir mounted to this log splitter. The unit is designed to be powered from a hydraulic system of another machine, such as a tractor or a skid steer. And this is my 1976 Economy Power King garden tractor. My intent is to power the log splitter from this tractor. The Power King does have an existing hydraulic system that works a 3-point hitch, but the pump is too small to power the log splitter. So I'm going to use the rear PTO, which utilizes belts to transfer power, to drive an auxiliary pump to operate the splitter. My plan is to make a frame that will support a 2-stage hydraulic pump and pulley, and to support this frame directly from the pre-existing mounts underneath the tractor. I will also have to provide a hydraulic fluid reservoir for the system, which I plan to mount alongside the splitter itself. I've taken the time to draw out my concept using FreeCAD, which is a free and open source drafting and modeling software. Within this model, the orange sections represent the tractor frame and pre-existing mounts. The green sections represent the frame which I will build and use to support a 2-stage hydraulic pump, rod coupler, pillow bearing, and 2-sheath pulley. I've decided to utilize a pillow bearing to support the pulley because I could not find a 2-stage hydraulic pump that was rated for a side load application. I'm using a 2-sheath pulley because I have 2 sheaves open on the rear PTO of the tractor, and I think that the extra belt will be beneficial in driving the pump under load. All of the steel that I'm using to construct the frame assembly I've gotten free from different construction sites. I try to scavenge and salvage what I can to keep costs low. But if I had to purchase the steel, I would have to say that what I'm using is perfect for its application. That is to say that what I'm constructing is not over-constructed or under-constructed. I'm using 2" by 2" by 3/16 inch angle iron to form the main part of the frame, 3/8 inch steel plate for the pump support and the bearing support, and I'm using 1" solid round rod for the pins that will rest within the pre-existing mounts underneath the tractor. Once every piece is cut to length, I will weld them all together. This is my general layout after I have cut all the pieces to length. I have drilled holes to accommodate the pins, and I have added another small section of steel for extra support of the smaller pins. I have also drilled holes to accommodate the bolts in the pillow bearing support, and I have drilled out for the hydraulic pump shaft and bolt holes. Notice that I have drilled a large enough hole to accept the shoulder around the pump shaft. This is an exact fit. I have also tapped the bolt holes in the pump support in order to prevent any interference between the bolts and the rod coupler. After everything is welded and cleaned, it's time to paint the frame and assemble the components. The components are in their general position. The position of the pillow bearing is incorrect, for it is backwards of its final position. It must be turned to 180 degrees in order for the locking collar to work. I turn it around off camera. The locking collar only works in one direction. When the frame and components are assembled, it's time to work on the hydraulic fluid reservoir. I've decided to construct my own reservoir and place it alongside the splitter. I'm using a section of hydraulic cylinder harvested from the demolition of an elevator for my reservoir. It has a 6" inside diameter, and I'm going to use a length of 60 inches. It should give me just over 7 gallons of space within the tank, which is comparable to the capacities of other log splitters I have viewed which use the same size pump that I'm using, which is a 16 gallon per minute 2-stage pump. I could probably go with a smaller size reservoir if I incorporate an oil cooler within the construction, but I'm trying to keep the cost of the project as low as possible. I'm using some sections of 3/8 inch steel plate to cap the cylinder. I've decided to cut octagons for the use as the end cap. Once cut, I drill holes in the octagonal plates in order to accommodate the inlet and outlet of hydraulic fluid. I have drilled a 1 3/8 inch hole in one piece and a 2.5 inch hole in the other. The holes are big enough to accept female weld-on connectors of 1 inch NPT and 2 inch NPT respectively. The 1 inch is to accommodate the return line from the valve assembly, while the 2 inch is for the installation of a screw-in strainer for the outlet line to the pump. After the female connectors are welded in place, the octagonal caps are welded on the cylinder. I then drill holes in the cylinder that will provide for a drain plug and a fill cap. I am using threaded rigid couplings for this purpose. After the welding and post-clean of the reservoir is finished, it's time to prime and paint. I've decided to try a self-etching primer. I don't have access to a sandblaster, and I'm hoping that the self-etching primer gives the paint better adhesion to the smooth cylinder. After painting, I have used 4-inch C-channel to construct brackets from which to support the reservoir from the splitter I-beam. I've welded 6-inch sections of C-channel directly to the reservoir and have drilled and tapped holes in these sections in order to bolt everything together. The reservoir sits about even with the top of the I-beam and sits far enough away so as not to interfere with the operation of the splitter. Now I've decided to skip showing the line and valve hookup of the splitter because the video is more about showing the hardware that actually powers the machine. But I do want to show how the pump and pulley bracket assembly fits underneath the tractor. The Power King has pre-existing mounts underneath the tractor which are used to support a variety of attachments such as a mower deck and snowplow. And it is within these mounts that the pins of the pump and pulley assembly rest. With the tractor running, the operation of the pump and pulley assembly is actually pretty smooth. I've had to utilize traditional V-belts instead of adjustable belts, which made the installation of the belts a pain in the neck. I tried using adjustable belts, which are much easier to install for this application, but even with 2 belts, they couldn't withstand the forces on the pump under high load. They broke only after a few actions of the log splitter. To install the V-belts, I had to unbolt the engine and move it forward to create a separation between the engine and transmission in order to have space to get the belts around the PTO sheave. I will not be removing them anytime soon. In fact, when the splitter is not in use, I plan to keep the belts in place, but I will support them so they do not rise on the PTO sheave. The whole system actually works better than I had hoped. The splitter works very well, and most of the time I can run the tractor at half idle to operate it, so my gas consumption is pretty low. I don't need to split wood all the time, so utilizing the tractor to operate the log splitter makes sense for me. In fact, I use the implements for this tractor seasonally, so switching between them isn't that much of a hassle, and it was a fun project. Hopefully, there is someone out there that can gain a little insight from what I've done here. Thanks for watching.